So now let's start the concept of measurements and experimentation. First, we need to understand that why do we need a unit for measurement? For that, we need to understand what is basically measurement. So measurement is the process of comparison of the given physical quantity with the known standard quantity of same nature. And we have different units of measurement, like for length we have centimeter, meter, kilometer, inch, feet, yard, etc. For area we have square centimeter, square meter, square kilometer. For capacity we have milliliter, we have liter. For volume we have cubic centimeter, we have cubic meter. For mass we have gram, kilogram, ton, pound. For time we have second, minute, hour. For temperature we have degree Celsius, degree Fahrenheit, degree Kelvin. And we have different kind of instruments, different kind of tool to measure different physical quantity, like micrometer, like we have vernier caliper, like we have protractor, like we have meter ruler. So now we are going to move towards what is a unit. Unit is the quantity of a constant magnitude which is used to measure the magnitudes of other quantities of the same nature. For example, physical quantity equals to numerical value into unit. And how a unit should be chosen? So a unit chosen should have following properties. The unit should be of convenient size. It should be possible to define the unit without any ambiguity. The unit should be reproducible, and most important, the value of unit should not change with space and with the time. It must always remain the same everywhere. So it should not be the concept like the value of liter is different in Kolkata and is different in Delhi. So this is not acceptable to be a standard of unit. Now coming to the concept of fundamental or basic unit versus the derived units. So fundamental unit is that which is independent of any other unit, or which can neither be changed nor can be related to any other fundamental unit. For example, meter for length, kilogram for mass, second for time, Kelvin for temperature. These are not derived from any other fundamental or any other unit. But when we talk about derived units, these are those which depend on fundamental units, or which can be expressed in terms of fundamental units. Let's have a look on the example. For the area, we have unit called meter square, and this meter has been derived from a fundamental unit which is of length. So area have unit meter square, and meter square is basically a derived unit of length. So this is basically the dependency concept. And here you can see the clear distinction between fundamental unit and derived unit. Now we have systems of unit, fundamental quantities, units and symbols in SI system. We have meter for length, which is written as symbol M, small m. We have kilogram for mass, we have second for time, we have Kelvin for temperature, we have candela for luminous intensity, we have ampere for electric current, we have mole for amount of substance, written as MOL, all in small letters. Now coming to the unit of length. So we have some bigger units like astronomical unit. Like one astronomical unit is equal to the mean distance between Earth and Sun, and it is equal to 1.496 into 10 to the power 11 meter. This is huge, and this is used to calculate the cosmic distance, the distance in spaces. Another unit which is even bigger than the astronomical unit is light year. A light year is the distance traveled by light in vacuum in 1 year, and 1 light year equals to 9.46 into 10 to the power 12 kilometer. This is even huge. Now comes the last one, parsec. 1 parsec is the distance from where the semi-major axis of orbit of Earth subtends an angle of 1 second. 1 parsec equals to 3.26 light year. That means parsec is the biggest unit among all these three. Apart from that, we also have some smaller unit which is angstrom. It is the 10 to the power minus 10th part of a meter. It is expressed by symbol A, and 1 angstrom equals to 10 to the power minus 10 meter. Next unit that we have is Fermi, which is even smaller than the angstrom. It is 10 to the power minus 15th part of a meter. So 1 Fermi, which is written as small f, equals to 10 to the power minus 15 meter. Now coming to the unit of masses. The SI unit of mass is kilogram, and there are some subunits of kilogram. Like for 1 gram, it can be written as 1 by 1000 kilogram, or 10 to the power minus 3 kg. 1 kg equals to 1000 gram. 1 milligram equals to 10 to the power minus 6 kilogram. 1 quintal equals to 100 kilogram. 1 metric ton equals to 1000 kilogram, or we can say it as 10 quintal. There are some non-metric unit of mass also, which are very smaller unit, like 1 ABU equals to 1.66 into 10 to the power minus 27 kg. One solar mass is equals to 2 into 10 to the power minus 30 kg. Apart from that, we have multiple units for time also. The SI unit of time is second. Now, apart from that SI unit, we have 1 minute for 60 second. We have 1 hour for 3600 second, or we can say it that 1 hour consists of 60 minutes. We have 1 day for 86,400 second, and for 1 year we have 365 days. For one leap year we have 366 days. For a decade we have 10 years. For a century we have 100 years, and a millennium consists of 1000 years. That is basically multiple subunits of time. Now coming to the derived units of some physical quantities. So for area we have meter square, for volume we have meter cube, for density we have kilometer per meter cube, for acceleration we have meter per second square, for force we have Newton, for work or energy we have joule, for momentum we have Newton into second, for power we have joule per second or watt, for pressure we have Pascal, for electric charge we have Coulomb or ampere into second. So these are some derived unit of some physical quantities, and these are the abbreviation which you can use while solving the numericals. Now coming to the vernier caliper, basically it is an instrument, it is a device which is used to measure the length of a rod, the diameter of a sphere, the internal and external diameter of a hollow cylinder, the depth of a small beaker or bottle, etc. Here you can see the picture of vernier caliper. Now we will see the function of each and every part of vernier caliper. Here you can see the label diagram of vernier caliper. Here is the outside jaw. These are used to measure the length of a rod, diameter of a sphere, external diameter of a hollow cylinder. Then we have inside jaws also. These are used to measure the internal diameter of a hollow cylinder or pipe. Then we have a strip. These are used to measure the depth of a beaker or a bottle. Then we have main scale. These are used to measure the length correct up to 1 millimeter. Then we have vernier scale, which is used to measure the length correct up to 0.1 millimeter. Apart from vernier caliper, we have another device which is screw jaws. Screw jaws works on the principle of a screw. It is used to measure the diameter of a wire or thickness of a paper, etc. Here you can see the image of screw jaws and function of each and every part of screw jaws. Here you can see the label diagram. First is ratchet. This is the ratchet. It is used to advance the screw by turning it till the object is gently held between the stud and spindle of the screw. Then we have sleeve. It is used to mark main scale and the baseline. This is sleeve basically. Then we have thimble. It is used to mark circular scale. Then we have main scale. It is basically located here. It is used to read length correct up to 1 millimeter. Then we have circular scale, which helps to read length correct up to 0.01 millimeter. Then we have measurement of time. We have simple pendulum. Simple pendulum is a heavy point mass known as bob, suspended from a rigid support by a massless and inextensible string. Here you can see the image of a pendulum. This is bob. This is the point of suspension, and this is what happens when we hit the bob. Like it goes and goes back. This is called to and fro motion. Now coming to the terms related to a simple pendulum, first is oscillation. One complete to and fro motion of the bob of pendulum is called one oscillation. Like for example, this is the point of suspension and here the bob is hanging. If we hit the bob, it will go to point A and then will go to point B. This is basically journey from point A to point B is basically a complete oscillation. Now period of oscillation or time period, that means the time taken to complete one oscillation is known as time period. When we hit the bob, the time taken to reach at point A and then came back to point B, this time is called as the time period or period of oscillation. Then we have frequency of oscillation, that it is the number of oscillation made in 1 second. Its unit is per second or hertz. Relationship between time period and frequency is like frequency equals to 1 by time or time period equals to 1 by frequency. So we can say that we have inverse relationship between frequency and the time period of a simple pendulum. Apart from that, we also have another term which is known as amplitude. Amplitude is the maximum displacement of the bob from its mean position on either side is called amplitude of oscillation. These terms we are going to discuss in the chapter sound in a very elaborative manner, so don't worry about that. Then we have effective length of a pendulum. This is basically the distance of point of oscillation from the point of suspension. We will learn what is point of oscillation, what is point of suspension in the sound chapter, and we are going to show the graph showing the variation of a square of time period with the length of a pendulum. So here we can see the graph. Here you see that with the time, with the increase in time, the frequency decreases because of the inverse relationship between time period and the frequency. Factors affecting the time period of a simple pendulum, there are some factors like here you can see the formula T equals to 2 pi under root length by G is gravitational constant. Usually it is taken as 9.8 meter per second square if not mentioned especially then. The time period of oscillation is directly proportional to the square root of its effective length. The time period of oscillation is inversely proportional to the square root of acceleration due to gravity. This G is basically acceleration due to gravity. We are going to study this concept in the further chapters. Then we have some other factors which do not affect the time period. So the time period of oscillation does not depend on the mass or material of body suspended. The time period of oscillation does not depend on the extent of swing on either side. Then we have seconds pendulum. Seconds pendulum is usually used in the wall clock. It is a pendulum with a time period of oscillation equal to 2 seconds, and this is known as second pendulum. So that's all in the chapter. Thank you for watching.